These are the solutions to the 2022 Leaving Cert Maths paper 1 at higher level. Question 1a. Find the two values of m, an element of the integers, for which the following equation in x has exactly one solution. So this question here is getting us to look at the discriminant, and the discriminant is given by part of our minus b formula, which is b squared minus 4ac. Now it's saying exactly one solution, so this is where my discriminant is equal to 0. The a is the coefficient of the x squared, the number in front of the x squared, that is, so that's 3. The b is the number in front of the x, which is minus m, and the c is equal to positive 3. That's the constant. I just fill those in now, so that's giving me b squared, which is minus m all to be squared, minus 4 times a times c, which is 3. That's equal to 0. So I'm trying to get that equal to 0. Minus m squared is m squared. Minus 4 times 3 is 36 is equal to 0. Add 36 to both sides, or move over that 36, becomes a positive 36. To get m on its own, it's the square root of 36. And the square root of 36 is plus or minus 6. And the question wanted us to find the two values of m. So that's positive 6 or negative 6. Looking at part B to that question 1, explain why the following equation in x has no real solutions. A couple of ways we could do it. Let's look at option 1 first of all, and I'm going to link it here to the discriminant, in fact. So I'm going to go about it the same way. So the first thing I could do is I could multiply out this square. So that means I'm multiplying it by itself. So 2x plus 3 times 2x plus 3, and don't forget to add in the 7 then. When I multiply that out, I get 4x squared plus 12x plus 9 plus 7 is equal to 0, which is 4x squared plus 12x plus 16 is equal to 0. And like I said, like in part A here, I could use my discriminant, so minus b, b squared minus 4ac, and it's no real solution, so I'm looking for less than 0 here. My a, the number in front of the x squared, my b, the number in front of the x, the c, the constant. So filling that in, I get 12 squared minus 4 times 4 times 16, and I'm showing that that's less than 0. So that's giving me 12, 144, minus 4 times 16, so 16 by 16 is 256 less than 0. And when I work that out, I get minus 112 less than 0. And there it's proved. Therefore, no real solutions because my value is less than 0. Now that's one way of doing it. An alternative way we could have done that question is by looking at maybe imaginary roots. So come back here to the original equation, 2x plus 3 all to be squared plus 7 equals to 0. If we subtract 7 or move that 7 over, that gives us 2x plus 3 squared is equal to negative 7. Let's try get rid of that square by getting the square root to both sides. So that leaves me with 2x plus 3 is equal to the square root of negative 7. Now we know we can't get the square root of a negative number, but if you're familiar with your complex numbers, that's the same as the square root of 7i is equal to 2x plus 3. Moving over that 3 becomes a negative, so 2x is equal to square root of 7i, take away 3, get x on its own, so that would be the square root of 7i, take 3 all over 2. And there's a imaginary root. There's our complex number for the value of x. So that's telling us that it has no real solutions. But maybe option 1 was probably the easier way to go because it links it to part A. Part C1. Show that x is equal to minus 1 is not a solution of the following equation. So look, to show if something's a solution, we can sub it into the equation and it should equal to 0. So if we sub in the minus 1 for x here, we get 3 take away, that's a plus there. So that gives me negative 2, yes, that's right. Plus 5 is equal to 0. That gives me 8 subtract 2 is equal to 0. 6 is equal to 0, and 6 is clearly not equal to 0. So therefore, not a solution. Not too hard on that part. See part 2. Find the remainder when 3x squared plus 2x plus 5 is divided by x plus 1. So using algebra here, and I'm going to divide x plus 1 into 3x squared plus 2x plus 5. X into 3x squared, well, that goes in 3x times. Multiply back down that 3x by x gives me 3x squared, and 3x by 1 plus 3x. Multiply across by minus 1, or change the signs here. 3x squared take away 3x squared will cancel, and 2 take away 3 gives me negative 1x. I'm then bringing down my positive 5. So I'm now dividing x into minus 1x, which gives me just minus 1. So multiplying back down that minus 1 gives me minus 1x, and minus 1 by positive 1 is negative 1. Same thing again, multiply across by a minus, or change the sign, so that one becomes a plus, that becomes a plus, they'll cancel, and then 5 plus 1 is 6. So that's basically just telling me, so therefore my remainder is equal to 6. And if we go back up to the question here, it says, that is, find the value of c when the following is written in this form. Now, I just want to check if that's true. So my answer here, we can move on if you wish. Remainder is 6, but I kind of just want to check this part here. So first thing I'm going to do is, if you look at this one, x plus 1, that's this. The next thing I'm going to look at is this part here, which is the ax plus b. That's my 3x minus 1. So 3x minus 1. And the final part is my c, which is my remainder, which is 6. So this is plus 6. And if you multiplied all that out, you should get 3x squared, and you do 3x squared plus 2x plus 5. And that's just a quick way of checking if you're happy enough for your value for c. So my answer there, remainder c, is equal to 6. Question 2a, g of x, 2x squared plus 5x plus 6. Find the integral of g of x. So this is basically just increase your power by 1, divide by your new power. So that's going to be 2x, increase my power by 1, becomes a 3, divide by my new power. This 5x is to the power of 1, so that'll be 5x squared over 2. And then the constant becomes 6x, because technically that's the same as 6x to the power of 0, and add 1 on to the 0 gives you 6x to the power of 1. Don't forget though, here at this stage, well, we can put that over 1 if you want, but don't forget to add on your constant. So 2x cubed over 3 plus 5x squared over 2 plus 6x plus c. Part B, the diagram below shows the function f of x. Well, they haven't given it to us actually. It's ax squared plus bx plus c. 3 regions on the diagram, k, l, and n. Each of these regions is bound by the x-axis, the graph f of x, and the 2 vertical lines. Part 1. The area of k is 538 square units. Use integration of f of x to show that 4x plus 3b plus 3c is equal to 807. Okay, so let's have a look at this. F of x from the question is given as ax to be squared plus bx plus c. That's what they're telling us. If I integrate that, I increase my power by 1, so ax to the 3 over 3 plus bx squared over 2 plus cx over 1 plus d. d is my constant. And I now need to find the integral of that in the region of, well, we're looking at the area of k, so that's going from 2 to 0. So I'm basically looking for the area of this region in here. So that's going to be ax cubed over 3 plus bx squared over 2 plus cx plus d from 2 to 0. So let's have a look at that. So if I sub in my 2 for x, I get a times 2 cubed over 3 plus b times 2 squared over 2 plus c times 2 plus my d. And then I subtract by subbing in the 0 for x, so a times 0 cubed over 3 plus b times 0 squared over 2. Look, I know I'm doing this, but you can hopefully see that it's just going to give you 0 anyway, so I don't need to write them all out, but I'm just going to do it. So that's giving me 8a over 3 plus 4b over 2 plus 2c plus d minus, well, that's just going to give me 0 plus 0 plus 0 plus d. And tidying all this up now a little bit, that'll give me 8a over 3 plus 2b plus 2c. And if you look at this part here, this d subtract d will cancel out. So d take away d is 0d. So I'm just leaving myself with 8a over 3 plus 2b plus 2c. And that is equal to, the question tells me that the area is equal to 538. So I'm letting that equal to 538 now. Now the question doesn't have a fraction. I have 8a over 3. They don't. So I need to multiply across by my highest denominator here, which would be 3. So this will give me 8a plus 3 times 2, which is 6b, 3 times 2c, which is 6c, is equal to 3 538, gives me 1614. Now I'm going to divide by 2, because I can see that all of these divide by 2. So that's giving me 2 into 8 is 4a, 2 into 6 is 3b, 2 into 6c is 2c, and 2 into 1614 is 807. And if you look back up the top here, that's the way they wanted it. So there's us showing that the area of K is the same as 4a plus 3b plus 2c equals to 807. And the final part, part 2, the area of the three regions K, L and N give the following three equations. Solve these equations to find the values of a, b and c. So this here is simultaneous equations with three variables would be the best approach. So let's look at looking at the first two. I'm going to take these two here first of all. So that's 4a plus 3b plus 3c is equal to 807, and 28a plus 9b plus 3c is equal to 879. Let's cancel out the c's here. So I'm going to multiply the top line by a -1. So that becomes a minus, becomes a minus, becomes a minus, becomes a minus. And the c's will cancel. So 28a take away 4a gives me 24a plus 6b is equal to 72. So there's one equation now. I'm down to two variables. I'm now going to come over and take the next two. I'm going to take the last two, in fact. So I'm going to use 28a plus 9b plus 3c is equal to 879. 76a plus 15b plus 3c equals 663. Again, cancel the c's. You have to cancel the same variable. So I'm going to multiply the top line by a -1. So that becomes a minus, becomes a minus, becomes a minus, becomes a minus. They'll cancel. So that's leaving me with 48a plus 6b is equal to -216. Okay, so now let's take these two equations here, these two, and solve for a and b. So I have 24a plus 6b is equal to 72, and I have 48a plus 6b. Okay, so it looks nice again here. The b's will cancel without doing too much work. So I'm going to multiply across by -1 on the bottom one. So this becomes a plus, minus, they'll cancel, becomes a minus. So that's giving me minus 24a is equal to 288. Get a on its own, I divide across by -24. That's giving me a value for a of -12. Okay, so we're a third of the way there. Now I want to find, so now find b. So the quickest way of doing this is just to sub it back in. So if I take either of these two lines, let's take the 48a line. 48a plus 6b is equal to minus 216. Let's sub in my value for a into this. My value for a is minus 12. So that's giving me large numbers here. I'm getting minus 576 plus 6b is equal to minus 216. Move that over, gives me 6b is equal to minus 216 plus 576, which is 360 is equal to 6b. b is equal to 360 divided by 6. So b is equal to 60. Okay, 2 found. Final one I have to find now is my value for c. And in order to find c, you just take one of your 3 original equations from the very start. So it doesn't matter which one you take. I'm going to take the very first one there. So now find c. And I'm taking the equation 4a plus 3b plus 3c is equal to 807. I'm going to sub in my value for a. I'm going to sub in my value for b. And I need to solve for c. A was minus 12. B was 60. So 4 minus 12 is minus 48. 360 is 180 plus 3c is equal to 807. So that gives me 3c is equal to 807 minus 132. So 3c is equal to 675. So c is equal to 675 divided by 3, which is equal to 225. So c 225, b 60, a negative 12. And that's question 2 done. Question 3a part 1, show that z minus I times z is equal to 8 minus 4i. So z is given as 6 plus 2i, so 6 plus 2i, so I'm substituting that in for z. Then I'm going I times z, well I'm substituting in 6 plus 2i for z. And hopefully when I multiply all that out and simplify, I get 8 minus 4i. So the first one stays as 6 plus 2i. I'm going to multiply in this I now, which is going to give me minus 6i minus 2i squared. And again, I want that to equal 8 minus 4i. Minus 2i squared. So I squared, it tells us in the question, to change that to minus 1. And I can group the positive 2i and the minus 6i to get negative 4i here, and then the 6 at the front. So that's giving 6 minus 4i plus 2 is equal to 8 minus 4i. And if we tidy that up a little bit, we have 6 plus 2 is 8. And subtract 4i. So 8 minus 4i is equal to 8 minus 4i. So part A, part 1, I've proved it's true. Part 2. Show that the modulus of z squared plus the modulus of iz squared is equal to the following. So just take your time with this one. There's 3 parts to it. First part I'm going to do is I'm going to work out the modulus of z squared. So we do know that z is equal to 6 plus 2i. That's what we're given in the question. Now the modulus formula is given by the square root of a squared plus b squared. So that's the formula for the modulus. A is the real part, so that's the square root of 6 squared, plus b is the imaginary part, that's the 2. We don't put in the I. So that's giving me the modulus of z is equal to the square root of 36 plus 4, which is the square root of 40. So that's the modulus of z. Now the question wants us to find the square root of the modulus of z, or sorry, the square of that. So I'm squaring the square root of 40, which is giving me a value of 40. So that's the first part done. Let's come over now and look at the next part, which is going to be the modulus of I times z all to be squared. Now go back up to the top of the question here, part 1. Do we know what I times z is? We do. We part worked it out. Well, we had a minus in front of it, so let's do it again. So iz is I times z, which is 6 plus 2i. Multiplying in the I, you get 6i plus 2i squared. 6i minus 2 times minus 1. 6i plus 2. Rearrange it, real part first, so 2 plus 6i. So that's the value of iz. I now need to get the modulus of iz. So once again, a squared plus b squared is my formula. And working that out now, sorry, a slight little mistake up there in the top of the question. It's 6i plus 2i squared. So just change, if you're following my work there, that's a minus 2 and that's a minus 2. So minus 2 plus 6i. So the modulus of I squared is equal to the square root of minus 2 all to be squared plus 6 all to be squared, which once again is giving me 4 plus 36, which is the square root of 40. And once again, they want us to get the square of that. So it's the square of the square root of 40, which is equal to 40. And you can see that that's the same as the modulus of z squared. Now let's come over and do the third one. The modulus of z minus I times z all to be squared. So filling it in, we have z, which is 6 plus 2i. I'm then subtracting I times z. Well, we have that from part 2, which is minus 2 plus 6i. So that was the second part we just did. Multiplying that minus into this bracket here. So that would give me 6 plus 2i, minus by minus is plus 2, minus by the positive gives me a negative 6i. Tidying all that up would give me 8 minus 4i. And I now need to find the modulus of that. So it's z minus I times z to be squared. So that's giving me the square root of a, which is 8 squared, plus b, which is minus 4 to be squared. Let's just get rid of that square there for a second. We'll worry about that in a minute. That's giving me 64 plus 16, which is the square root of 80. Now we'll worry about the square. So it's z minus I times z all to be squared. So I'm squaring the square root, which is positive 80. And you can hopefully see now that we're practically there. My last little step is just to come back to the very start of the question because it says show that. So I need to show that the modulus of z plus the modulus of iz is equal to the modulus of z minus I times z all to be squared. So what did we get z squared to be? We got it to be 40. I times z all to be squared, we also got to be 40. And the value for the right hand side, we got to be 80. And here I've got 80 is equal to 80. So therefore true. A part 3, the circle C passes through the points Z, IZ and 0 as shown in the diagram below, not to scale. Z and IZ are endpoints of the diameter of the circle. Find the area of the circle C in terms of pi. The space on the next page, I'm just going to work both of them, or my answer out here around the circle just so we can follow the steps and use the diagram for assistance. So let's fill in everything we know. So O is the origin, so that's obviously going to be 0, 0. The point IZ we found out in part 2 to be minus 2 6i, so that's a positive 6i, so that's that coordinate, and the coordinate of z is 6 plus 2i. So that's everything we know. We know actually the distance from the origin out to z is the square root of 40 because that was the modulus from part 2. The modulus stands for the distance from the origin to the coordinate. And we also know that the distance from the origin to I times z is also square root of 40. So that's everything we know. Now there's two ways we can work out the area of the circle. Well, in order to find the area of a circle, first of all, we need to get the radius because the formula for the circle, area of a circle, is given as pi r squared. So in order to get the area, we need the radius. So to get the radius, there's two ways of doing it. I'm going to do option 1 over here and option 2 on this side. Option 1 is simply just to get the distance from the two coordinates, z and iz, and then half that distance to get the radius, because I'm getting the diameter here. So if I take my 2 points are minus 2 plus 6i and 6 plus 2i. And I use the distance formula for my log tables, x2 minus x1 all to be squared, plus y2 minus y1 all to be squared, all in a square root. Label my 2 points, x1, y1, x2, y2. Filling that in, I get, what are we getting? We're getting 6 minus minus 2 plus 2 minus 6. Again, I don't need to put in the i's here, which is giving me a distance of 8 squared, which is 64, plus minus 4 squared, which is 16, which is giving me a distance of the square root of 80. Yeah, okay. Actually, we have that up from part 2 as well, but nonetheless, we've done it out. So the distance between my 2 points on the circle is the square root of 80. Now, another way you could have done that is looked at the triangle in the circle. This would be iz, down to z, back to the origin. The triangle which goes through the diameter of a circle and touches the point on a circle is a 90-degree triangle. So we could have used Pythagoras' theorem here also to get the square root of 80. Let's just do it out to be sure. So this would be my c here, the hypotenuse. So c squared is equal to square root of 40 squared plus the square root of 40 to be squared, which is 40 plus 40 equals c squared. C then is equal to the square root of 80. So both options are fine. Let's come back now and find the area of the circle. So just to be clear here, the diameter is equal to the square root of 80. So the radius is equal to the square root of 80 divided by 2. Wouldn't that be right? Which is, on my calculator, 2 square root 5. So the radius is 2 square root 5. So filling that in to my area of the circle, pi times 2 square root 5 all to be squared, wants it in terms of pi. So that's an area of pi times 2 square root 5 all to be squared, which is giving me an area of 20 pi units squared, because we don't know if it's centimeters or anything like that. So 20 pi is our answer here. B, square root of 3 minus I to the power of 9 can be written in the form a plus ib, where a and b are elements of z and I squared is minus 1. Use de Moivre's theorem to find the values of a and the value of b. So if I'm using de Moivre's theorem here, first thing I need to do is write my complex number in polar form. So I need to convert the square root of 3 minus I into polar form. So that's my first step. And my a here is the square root of 3. My b is the number in front of the I, which is negative 1. My polar form is r times cos of theta plus I sine of theta. The radius then is given by the square root of a squared plus b squared, the modulus. And that's giving me square root of 3 all to be squared plus minus 1 all to be squared in a square root. So my radius here is the square root of 3 plus 1, which is the square root of 4, which is 2. So r is 2. Next thing I need to do now is find my angle, my theta, my argument. So that's giving me theta is equal to tan inverse of b over a. So the angle is equal to tan inverse of minus 1 over the square root of 3, which is giving me minus pi over 6, or 1/6, minus 1/6 pi. I'm going to work to the positive here, so I'm going to add on 2 pi here. I don't want a negative solution. So that's giving me a theta, an angle of 11 over 6 pi. So if I come over now and fill that into my polar form, or times cos theta plus I sine theta, filling in my or, which is 2 times cos of 11 over 6 pi plus I sine 11 over 6 pi. Okay, next thing I need to do now is come back to the top of the question. What does it want? It wants us to evaluate it when it's to the power of 9. So I'm looking for the square root of 3 minus I to the power of 9, which is the same as my polar form, 2 times cos of 11 over 6 pi plus I sine 11 over 6 pi, all to the power of 9. Now, if I use my de Moivre's theorem, it simply just tells me to put the 9 to the power of the 2, the or, and then I multiply the angle by 9 as well. So that's then going to be cos, I'll just change the color here so you can see what's happening, 9 times 11 over 6 pi plus I sine 9 times 11 over 6 pi. And 2 to the power of 9 is giving me 512 times cos of 33 over 2 pi. So when I multiply 11 over 6 by 9, plus I sine 33 over 2 pi. Make sure your calculator now is in radians form, so I need to multiply in this 512, and that's giving me 512 by cos 33 over 2 pi is 0, and multiplying 512 by sine 33 over 2 pi is 512, because sine 33 over 2 pi is 1, and don't forget to put back in your I, and that's us finished. So A in this case would be 0, B would be 512. A sequence U1, U2, U3 is defined as the following, where write U3 in the form 2 to the power of P, where P is an element of the real numbers. Okay, so we're trying to find U3 here. And another way of writing U3 would be the same as U2 plus 1, because if you look at the question there, it tells us that any term is found by going un plus 1. So to get to 3, I would go 2 plus 1. And if we bring that a little bit further and using this now, that's the same as the square root of un. So un would be u2, because we're coming from here. That's my un, in other words. And I'm dividing that by un minus 1. So un minus 1. Now that's a small n and a small 1. So that would be u2 subtract 1. So I have the square root of u2 over u2 minus 1. And the value of u2 from the question is 64. And that's over the value of u2 take away 1. Well, that's u1. Now we also know the value of u1. It's 2 from the question, which is giving me the square root of 32. Now the question wants it as a power, so I'm just going to bring that up here. So it's the square root of 32, which is the same as 32 to the power of a half. It wants it to 2 to the power, so 2 to the power of 5 is the same thing as 32, so I can write it as 2 to the power of 5 to the power of a half. I'm using my log tables here really. And then to write it as a single fraction, I multiply the 5 by the half, so that's 2 to the power of 5 over 2. So 2 to the power of 5 over 2 is the same as the square root of 32. B part 1. The first three terms of an arithmetic sequence are as follows. By letting y is equal to e to the power of k in this arithmetic sequence, show that the following. An arithmetic sequence, as we know, is one where it has the same constant difference between each term. So they're giving us a little hint here, and they're telling us to let y is equal to e to the power of k. Now, if we look at our sequence in the question here, they have it started as 5e to the power of minus k, followed by 13, followed by 5e to the k. Now, if we rewrite 5e to the minus k, that's the same as 5 times 1 over e to the positive k. So we know that that's the same thing if we have a negative power. So that's the same as 5 over e to the k if we write it as a single fraction. And I'll just put in my other two terms here. So my sequence is the same as 5 over e to the k, 13, and 5 e to the k. Now I'm going to let my e to the k as y, so that's the same as, so therefore my sequence is now 5 over y, 13, and 5 times y. So that's my sequence. Next thing I'm going to do is look at the way they want our answer. They want it to be 5y squared minus 26y plus 5. So what I'm now going to look at here is, how do I get the difference between two terms? So you know the way we take two terms away from each other to get the next term, or to get the previous term. So that's the same as if we look at any term, so I'll call it tn plus 1. And if I take away the term before it, so tn in other words, that would give me the difference, the common difference. So say for instance, if I want to find, if I go t3 take away t2, I get the common difference. And that's what I'm going to do here. So I have three terms. So if I go term 3, subtract term 2, that gives me the difference. But that's the same as maybe going term 2 take away term 1. They're both giving me the common difference. And I know those first three terms, t1, t2, and t3. So subbing in t3, I have 5y. Subbing in t2, I have 13. And I'm letting that equal to t2, which is 13, subtract t1, which is 5 over y. I'm now just going to multiply across the whole line by y to get rid of that fraction really. So 5y by y gives me 5y squared, 13 by y is 13y, another 13y, and then 5 over y times y, the y's will cancel, which is just leaving me with 5. If I rearrange it, tidy it up, move everything to the left hand side, that will give me 5y squared minus 13y plus 5 is equal to 0. And grouping the 13s gives me minus 26y plus 5 is equal to 0. And lo and behold, that's what they wanted in the top of the question. 5y squared minus 26y plus 5 is equal to 0. Part 2 to this question is use the equation in y in part b, part 1 above to find the two possible values of k. And give your answer in the form lnp or minus lnp. So the equation we found in part 1 was given as 5y squared minus 26y plus 5 is equal to 0. Now because the question wants our answers in log form, I know that it has to be like a decimal, so I'll need to use my minus b formula here. So from my log tables, y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And filling that in, my b is negative 26, so minus 26, plus or minus the square root of minus 26 squared, minus 4 times a, which is 5 times c, which is also 5. And that's all over 2a, which is 2 5s. And tidying up a little bit more, I get positive 26 plus or minus 676 minus 100, all over 2 5s, which is 10. So that's giving me y is equal to 26 plus or minus 576 over 10. So I have now got y is equal to 26 plus or minus the square root there gives me positive 24 over 10. So therefore y is equal to 26 plus 24 over 10. And y is equal to 26 minus 24 over 10. So my two values for y here are 5 and y is equal to a fifth. So I solved for y, but the question in part 1, if you scroll back up, is looking for k. And the question asks us here to find two possible values for k. So I know that y is equal to 5 and y is equal to 1 over 5. Now, if we substitute back in our e to the k for y, that means e to the power of k is equal to 5, and e to the power of k is equal to 1 over 5. And if I now use my log tables here, page 21, to solve for k. So this is the top right hand corner of my log table. So I'm using log base e to the 5 is equal to k, and log e to the 1 over 5 is equal to k. Log to the base e is the same as the natural log, so that's the same as ln 5 is equal to k, and log e is the same as ln again. 1 over 5 is equal to k. So the question here says I have lnp and minus lnp. Well, there's my first value. ln 5 is equal to k. But my second value, if you go to your log tables on page 21 again, middle column down the bottom, it gives log a 1 over x is the same as minus log base a to the x. So I'm going to use that here now to give me a negative ln 5. So there's my two values for k. Question 5a, g of x is equal to x squared minus 1 over x. Find g dash of x, the derivative of g of x. So our function here, g of x, let's just write it down, is equal to x squared minus 1 over x. First thing I'm going to do here is, before I differentiate it, I'm going to turn the 1 over x into 1x to the power of negative 1. So when I have a fraction, I always want to get rid of the fraction by bringing it up and putting it to the negative power. So now I'm going to differentiate it. And to differentiate it, I bring down the power multiplied by the factor in front of the x, or the coefficient of the x, and reduce the power. So that becomes 2x to the power of 1. And bringing down the power here and multiplying it, so I'm multiplying minus 1 by negative 1, so that'll become a plus 1. X reduced the power becomes x to the minus 2. And then put it back together, so that's giving me 2x plus 1 over x squared. So always turn your answers back into fraction form without the negative power. Looking now at part B, f of x is given by the following, and part 1 is saying x plus 1 is a factor of f of x. Find 3 values of x for which f of x is equal to 0. Okay, so they've given us one of the factors. First thing we need to do is find the other 2 factors. So to do that, it's a cubic, so there's 3 factors. I need to use long division, would be one method. So I'm going to divide x plus 1, and I'm dividing it into 2x cubed minus 21x squared plus 40x plus 63. So I'm using long division here. X into 2x cubed becomes 2x squared. Multiply that back down, gives me 2x cubed plus 2x squared. I'm multiplying across by negative 1, or changing the signs here. So 2x cubed minus 2x cubed will cancel, and minus 21x squared minus 2x squared will give me negative 23x squared. I'm then bringing down my 40x, so that's a positive 40x, and I go again. I'm now dividing x into minus 23x squared, so that'll give me minus 23x. Multiply that back down, minus 23x squared, and then 1 by minus 23 is minus 23x. Same thing again, change the signs, or in other words, you're multiplying across by negative 1, so that now becomes a plus this time. Minus 23 plus 23 will cancel, and positive 40 plus positive 23 will give me positive 63x. And now I'm going to bring down my constant, the plus 63. And final time, divide it in. X into positive 63x will go 63 times, so plus 63. Multiply that back down. 63x, and 63 by 1 is plus 63. Change the signs, multiply across by -1, in other words. Cancel, cancel, remainder 0. Okay, so once you've divided it in, you now have a quadratic on the top. So I now have my factor x plus 1, but I have another factor here, which is 2x squared minus 23x plus 63. Now, so I've left myself with a quadratic equation here, 2x squared minus 23x plus 63. So I'm going to use my minus b formula here for my log tables to factorize this. So x is equal to minus b plus or minus the square root b squared minus 4ac all over 2a. A is my 2, b minus 23, c positive 20 or positive 63. So x is equal to minus 23 plus or minus the square root of negative 23, all to be squared, minus 4 times a times c, all over 2 times a, which is 2 times 2. And when you do that out, you get x is equal to positive 23 plus or minus the square root of 25, so that'll give me a 5 over 4. So running out of space here, so let's bring all that up here. So that means that x is equal to 23 plus 5 over 4, and x is equal to 23 minus 5 over 4. So x is equal to 28 over 4, and x is equal to 18 over 4. So x is equal to 7, and x is equal to 9 over 2, which is 4.5. So there's two values for x, 7 and 4.5. Now let's come back to our original factor here. Remember, we had a factor which was x plus 1. So x plus 1 was our factor. I want to turn that into its root. So this is my factor. Changing that to a root, I let it equal to 0, and that gives me x is equal to minus 1 as my root. So my third root is negative 1 here. The order doesn't matter. Minus 1, 4.5, 7. Part 2. Find the range of values of x for which f dash of x is negative. So this is the derivative is negative. So my derivative from the previous part of the question was f dash of x is equal to 6x squared minus 42x plus 40, and I'm looking for less than 0. Now, I haven't factorized the derivative in the previous part, so I need to factorize this now. Once again, I'm going to my minus b formula, so x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. A is 6, b minus 42, c 40. So x is equal to minus 42 plus or minus the square root of 6 squared minus 4 times a times b. Sorry, that's wrong there. My b in the first bracket here should be minus 42. Minus 4 times a times c. All over 2 times my a, which is 2 sixes. And when I evaluate that, I'm getting x is equal to 5.86 and x is equal to 1.14. So if I sketch that out on my coordinate graph here for a second, so this is my y-axis and my x-axis, and I plot the 2 points here. It's only a sketch. So I have 1.14 and I have 5.86. It's a positive quadratic, so it looks something like that. And the question is looking for where it's negative, so that's below the x-axis. So I'm basically looking for this region in here. I'm looking for everything here. So it's between, x has to be between positive 1.14 and positive 5.86. So therefore, my final answer here is x is between 5.86 and 1.14. If you're ever doubtful with your two solutions, just sub them back into your quadratic equation and see for yourself that they are less than 0. Question 6a, differentiate f of x with respect to x from first principles. So when we're using our first principles, we're looking at the limit as h approaches 0, and I go f of x plus h minus f of x, and I divide that all by h. So that's how we find our first principle, differentiating from first principles. Now, for my formula, I need f of x and I need f of x plus h. So I know what f of x is. F of x, they give it to me in the question. It's given as 2x squared plus 4x. So that's fine. Next thing I need to find though is f of x plus h. So in this case, I'm basically subbing in x plus h for x. So I'm going 4 times x plus h. Now I need to tidy that up, so I need to multiply out these brackets. So something squared means it's by itself, and then 4 times x plus h. Multiplying this in, I'm going to just multiply into 2 first of all. So that's going to give me 2x plus 2h times x plus h, plus, and I'll multiply in this 4 now, which is going to give me 4x plus 4h. Multiplying in these two brackets now is going to give me a 2x squared plus 2hx plus 2hx plus 2h squared. And then add on your 4x plus your 4h. So my final line here for the value of f of x plus h, tidying it up, is going to be 2x squared plus 4hx plus 2h squared plus 4x plus 4h. I don't think we can tidy that up any further. So that's my little bit of rough work done. I'm going to come back up now and sub all that into my limit formula. So I have the limit as h approaches 0 is equal to f of x plus h. Well, f of x plus h is now given as 2x squared plus 4hx plus 2h squared plus 4x plus 4h. I now subtract, so let me just put that in a different color just to make sure we know what we're doing. And I'm subtracting f of x, and f of x is 2x squared plus 4x. And I need to put that all over h. My next step now is going to multiply in this minus, so take everything out of brackets. So I have the limit as h approaches 0 is equal to 2x squared plus 4hx plus 2h squared, 4x, 4h. Multiplying in that minus now will give me a negative 2x squared and a negative 4x. Once again, don't forget it's all divisible by h. So my next step, limit as h approaches 0 is equal to. Now, I'm hoping things will start cancelling on the top line of my fraction. So you can see here, for instance, the 2x squared cancels with the minus 2x squared. Positive 4x cancels with negative 4x. So my top of my fraction is now going to look like 4hx plus 2h squared plus 4h, all divided by h. I now need to divide the top line by h. So one way of looking at it is maybe if you want to factorize out h from the top line. So if I factorize out the h, it'll be h times 4x plus 2h, because h by 2h is 2h squared, plus 4. And that's divisible by h, and then the h's will cancel. So that's leaving me with the limit as h approaches 0 is equal to 4x plus 2h plus 4. Slightly running out of space here, so I'm just going to bring it up here. So I'm just going to make a little bit of room for my last little step. So bringing that up, I have the limit as h approaches 0 is equal to 4x plus 2h plus 4. Now what I'm doing now is I'm looking at the limit as h approaches 0. So I'm basically subbing in the value for h. So I'm going 4 times x, sorry, that's 4x. So 4x plus 2 times h. Well, h is approaching 0 at my limit, plus 4. So that's giving me 4x, 2 zeros are nothing, plus 4. So that my derivative here is 4x plus 4. So differentiating 2x squared plus 4x, f dash of x is 4x plus 4. Part B, a rectangle is expanding in area. Its width is x centimeters. its length is always 4 times its width. Find the rate of change of the area of the rectangle with respect to this width x when the area of the rectangle is 225 centimeters squared. So first thing I'm going to do here is draw out our rectangle. So let's look at it out here actually to the side. So I have my rectangle here. And what do I know about it? I know its width is x. And then they tell me that the length is always 4 times its width. So 4 times its width is 4 times x. So that's basically my rectangle. Now the question focuses in on area of rectangle. So the formula for the area of a rectangle is given as length by width. Now I know my length and width here. Length is x and width is 4x. Or vice versa. And multiplying that in, I get area is equal to 4x squared. So that's the area of my rectangle here. Now the question is talking about rate of change, which is around differentiating. So I'm going to differentiate the area with respect to x here. So that would be dA dx, and differentiating 4x squared gets me 8x. Okay, so that's my rate of change. Now if we come over here and look at it in another way, the area of my rectangle is 4x squared. That's it in terms of x. But the question tells us that the area of the rectangle is 225. So I'm letting them equal to each other because I know what the area is. Now if I solve this for x, I have x squared, divide across both sides by 4. And to get x on its own, I get the square root of 225 over 4. And the square root of that is giving me 15 over 2, or 7.5 on my calculator. And now what I'm going to do with that is I'm going to bring that back to my rate of change. So remember we have dA dx, we have a value of 8x. I now have the value of x when the area is 225. So I'm basically going to sub in my value for x, which is 15 over 2, 7.5. And when I multiply that out, I get 60 centimeters. What's it asking? Find the rate of change of the area of the rectangle. Yeah, so that would be 60 centimeters squared. That's the change in the area with respect to the sides, which are in centimeters. So maybe something like that, 60 centimeters squared per centimeter. Part C. The graph of a cubic function p of x is shown in the diagram below in the domain 0 to 4. The maximum value for the derivative of p in this domain is 1, and p dash of 0 is minus 3, where p dash of x is the derivative of p of x. Use the information to draw the graph of p of x in the second set of axes below in the domain 0 to 4. So as we look at it here, the graph of p of x is a cubic function, and it's a negative cubic function. And when you differentiate a cubic function, you get a quadratic function, and we're looking at a negative quadratic here. And just as a little bit of rough work here, we know that a negative quadratic must look something like that. A couple of things we can use here to find out where it crosses our x-axis for my p dash of x. The quadratic will cross the x-axis at the maximum and the minimum turning point of the cubic. So here's the minimum and here's the maximum of the cubic. And if I just drop down dotted lines here, so here at 3 and at 1, they're the roots basically of my quadratic function. So there's two things found. Next thing we can use is our knowledge of the point of inflection. The point of inflection is basically halfway between the maximum and the minimum. So it's this point here. And that point basically will indicate the turning point of our quadratic. So I'm just going to drop that blue line down here. Now, we need to figure out where is that turning point of our quadratic. It tells us in the question here that the maximum value of p dash of x in the domain is 1. So that's telling us the highest value for x is 1. Or sorry, for y is 1, our p dash of x is 1. So that's telling me my point here at 2, 1 is the maximum turning point of our quadratic. Now, what else do we know? In the question, it also tells us that when x is 0, my value for the derivative is minus 3. So the point there is 0 minus 3, and 0 minus 3 on my graph would be here. So there's another point on our graph. So if I basically just connect these dots freehand, now it's quite hard on the screen here, but easier on paper. Let me start again. It's gone off already. So it looks something like that. Now we know though that it's a quadratic, and a quadratic is symmetrical across its left and right of its center line. And the question wants us to sketch it in the domain 0 to 4. I've only sketched it there from 0 to 3. So I technically need to continue that, that curve down to here. That should be crossing the point 4 minus 3. So there's the sketch of the derivative. Question 7a, work out Hannah's heart rate 4 minutes after the start of the session. So we're given the function here, h of x. I'm subbing in 4 for x, so x is standing for the time, and that will give me the heart rate after 4 minutes. So I'm basically solving for h of 4 here. So that's going to give me, let me just write out my function here, and I'll write in my value for x then. So subbing in 4 for x, and when I evaluate that, I'm getting h of 4, or her heart rate after 4 minutes, which is giving me 162 beats per minute. So nothing too hard there. Part B, find h dash of x. That's asking me to find the derivative of h. So let's just write out the original function. It's good practice to write the original function first. 2x cubed minus 28.5x squared plus 105x plus 70. Differentiating that, I multiply the power down and I get 6x reduced to power by 1, so 6x squared. Multiply 28.5 by 2, I get 57x reduced to power by 1. And differentiating 105x is 105. Drop the constant then. So h dash of x is equal to 6x squared minus 57x plus 105. Part C, find h dash of 2 and explain what this value means in the context of Hannah's heart rate. So once again, I'm basically subbing in 2 for x, but just make sure that you're subbing it into the derivative. So 6 bracket something squared minus 57 times my value for x. So that's giving me 2, I'm subbing in here. So working that out, I get h dash of 2 to be 15. The next part of that question is asking us for an explanation to that. Don't forget that when you find the derivative of something, you're finding its rate of change. So a couple of ways we can write this here. So it represents the rate of change, because that's what dy dx basically is. And in the context of this question, I'm just going to say, i.e. the rate of her heart is changing with respect to time. And time in this question is in minutes. So it's basically the rate of change, how her heart rate is changing as time goes by. Looking at part D, the graph below shows y is equal to h of x. Find the least value and the greatest value of h of x. Use calculus in your solution, may use information from the graph above, which is to scale. So I'm sure a lot of people probably use the graph here. I'm going to use a mix and match here. First of all, it's saying to use calculus to find the least and greatest. Thinking of least and greatest, we're thinking max and min turning points here. But as you look at the graph, this is going to be my minimum turning point, which we can use calculus to find, and this is going to be my max turning point, which again we'll use calculus to find. But that's not, that minimum point here is not actually going to be my lowest one on the graph. The lowest point on the graph is actually going to be here. You can see here that that's below the minimum turning point. So they're trying to maybe catch us out there between using the minimum turning point and actually the lowest value from the graph. So finding that one there at the lowest point, first of all, well, that's going to be at time 0 here. It's going up to 8 seconds. We're looking at time 0. So basically, I'm going to just take my function from part A, which is h of x equals 2x cubed minus 28.5x squared plus 105x plus 70. And basically what I'm going to do here is I'm going to sub in 0 for x. I'm finding basically h of 0. So 2 times nothing cubed minus 28.5 times 0 squared plus 105 times nothing plus 70. So this is going to give me 0 minus 0 plus 0 plus 70. So the lowest point, or the least value, is going to be at h of 0, which is 70. So that's my least value. So that's my first one found. That's my least value of h of x. Now I'm going to find the maximum value for h of x, and I'm going to use calculus now for this, and this is going to use my minimum and turning point from my calculus chapter. And in order to find your minimum and maximum turning point, so min max is going to use calculus dy dx. So first derivative, and I let that equal to 0, and I solved that for x and y then. So I'm basically differentiating h of x. So going from the top of page 16, this the start of this question, differentiating 2x cubed has given me 6x squared. 28.5x squared differentiated gives you 57x. I'm basically multiplying down the power, and the 70, the constant, is just dropped. So 6x squared minus 57x plus 105. And to find max and min, I'm going to let that equal to 0 now. And then I'm going to use my minus b formula to solve that. So I'm going to my log tables, taking down my x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And subbing that in, I'm getting x is equal to minus 57 plus or minus the square root of minus 57 squared minus 4 times 6 times 105. Okay, so fairly large numbers here. And I'm putting all that over 2 times a, which is 2 times 6. And when you evaluate that, I'm getting x is equal to 57 plus or minus 27 all over 12. So I'm just going to bring it up here because I'm running out of space here now. So I need to do them both out for the plus and minus value. So x is equal to 57 plus 27 over 12. And x is equal to 57 minus 27 over 12. So that's giving me two values. X is equal to 2.5 and x is equal to 7. Sorry, I've just got them the wrong way around there. This one is 7 on my calculator and the negative one should be 2.5. So there are my two values for x. Coming back up to my picture though, let's just match these up with the max and mins. So here you can clearly see that the 7 would be around here. So that's going to be my minimum. So you can sub both of them in if you want. But coming over here now, looking at the x equal to 2.5, that would be more than likely this one. So that's my 2.5 seconds. So my maximum is going to be when x is equal to 2.5. But you can test both of these yourself. But trust it here, it'll be 2.5. So basically what we now need to do is we need to let x equals to 2.5 and sub it into my h of x, my original function. So that's this function here. So I'm subbing it into this, h of x. So I'm getting h of 2.5, which is equal to 2 times 2.5 cubed minus 28.5, 2.5 squared, plus 105 times 2.5, and then plus my 70. And when you work that out on your calculator, you're getting h at 2.5 to be 185.625. So that's going to be my greatest value. So a little bit of a trick maybe, or trying to catch us out perhaps in that question, particularly in the least value. So my greatest, 185.625, and my least was 70. Now again, if you put in x equals 7, you should get out 94.5, but that's not the least value. The least value should be 70. Looking at part E, how long after the start of the session is Hannah's heart rate decreasing most quickly within the first 8 minutes? Give your answer in minutes and seconds. So they've given us h of x there again. So where the point where her heart rate would be decreasing most quickly, given that this is a cubic function, would be the point of inflection of the curve. Now the point of inflection is found from finding the second derivative and letting that equal to 0. So I have my, let's just go through all this again. So I have my original function h of x, which is 2x cubed minus 28.5x squared plus 105x plus 70. I found my first derivative earlier to be 6x squared minus 57x plus 105. And I'm now going to differentiate for a second time. So the second derivative, which is 12x minus 57. And I'm now going to let that equal to 0 for my point of inflection. So letting my second derivative, 12x minus 57, is equal to 0. Adding 57 to both sides, 12x is equal to 57, x is equal to 57 over 12, which is x equals to 19 over 4. Now, if you want to work in decimals, that's 4 3/4, 4.75. It's asking us to find how long after the start of the session. So I don't need to sub that in because it's not asking me to find the heart rate. So my answer there is 4.75 minutes. Now the question is asking us to put our answer in minutes and seconds. So that's giving me 4 minutes, and 0.75 of a minute is 3/4 of a minute, which is 45 seconds. And if you're doubtful, you just multiply 60 by 0.75. So 4 minutes and 45 seconds would be the time. Looking at F, Bruno, Karen and Martha start a training session at the same time as Hannah. All of their heart rates are measured in beats per minute. Part 1, for the first 8 minutes of the session, Bruno's heart rate, B of x, is always 15 beats per minute more than Hannah's. Use this information to write B dash of x in terms of H dash of x. Okay, so Hannah's H dash of x, which we found earlier, is 6x squared minus 57x plus 105. Now it's telling us that Bruno's is 15 beats per minute more than this. So I'm now trying to find B dash of x. So basically all I have to do here is take Hannah's and add on the 15 extra beats, so plus 15. So my Bruno's heart rate is going to be 6x squared minus 57x plus 120. Part 2, for the first 8 minutes of this session, Karen's heart rate, K of x, is always 10% less than Hannah's heart rate. So once again, I need Hannah's H of x, which is 6x squared minus 57x plus 105, found elsewhere. And I'm getting Karen's now, so K dash of x, and it's 10% less than Hannah's, which would be 90% of Hannah's. So if something's 10% less, so 100 minus 10 is 90%. 90% as a decimal would be 0.9. So 90% times 6x squared minus 57x plus 105. So 10% less means it's 90% of it. Yeah, so 0.9 times Hannah's. Part G, Martha does each exercise for a longer time than Hannah for x between 0 and 10. Martha's heart rate is m of x, and it's given as m of x is equal to h times 0.8x. Use h of x to write m of x in the following form. Okay, so look at the first part here. We have h of 0.8x. Now, we know what the value of h of x. We know the value of h of x previously is 2x cubed minus 28x squared plus 105x plus 70. So if I'm trying to find h 0.8x, I'm basically subbing in 0.8x for x, if that makes sense. So I'm basically going 2 times, let me just write all this out first, and then I'll sub in my value for x. So the value for x here is 0.8x. So I'm substituting x with 0.8x. That's what's happening here, and that one's cubed, don't forget. And working that out on my calculator, I'm getting 128 over 125x cubed minus 456 over 25x squared plus 84x plus my constant of 70. And if you want to turn them to decimals, if you're working in decimals, that's the same as 1.024x cubed minus 18.24x squared plus 84x plus 70. The question said where a, b, and c and d are elements of the real numbers. So decimals or fractions are fine. Question 8a, complete the table below. The value of h1 is given to us. So basically all we're doing here is we're subbing our t, our time, into our function h of t. So for instance, let's say we do this one here. So we're finding h of 3, which is equal to taking my function 72 minus 60 times cos times pi over 3. So just make sure your calculator is in radians for this question, and I'm subbing in 3 for t. So that's basically what I'm putting into my calculator. And for my first value there, for say h of 3, I'm getting 132. So I've done these out, so I'm getting 12. Actually, what you could have done in your exam here, or if you're doing it as practice, you could have tested t of 1, and you should have got 42. And filling in the rest of them, 102, 132, 102, 42, because it's going around in a circle, so that's why these are repeating each time. 12 when it's at its lowest, 42, and 102. It's then asking us in part B to sketch the function, draw the function h of t between 0 and 8. So my first point there to plot is going to be 0, 12, which is here on the y-axis. My next point then is 142, which is here. And my final point, 8, 102. So there's my points plotted. I now need to create a freehand curve connecting all of those points. Which should look something like that. And I should just rub off ignore this part here and at the end here, because it's between 0 and 8. So looking at part C, find the period and the range. The period is how often the curve repeats, and the range is basically the maximum to the minimum. So we'll start with the range. Actually, it could be a little bit easier. So if I'm looking at the range, first of all, the minimum point or the lowest point of the Ferris wheel is at 12. So we can either take that from my curve here, it's coming across to 12, or if you go back to the original drawing they gave you, you can see here that the lowest height is 12 meters. So that's my minimum on my range. And my maximum, again, you can take these from your table as well, which is 132. So once again, I can use my my sketch to come across to my 132, or you can come back to your table and take it from here that the highest point is 132. So there's numerous ways you can get those values. So that's 132. And the next part is asking us to find the period for the function. So how often does the function repeat? And this function repeats every 6 minutes, because if you go from, say, time 0, it's at 12 meters. When is it at 12 meters again? Well, it's at 12 meters again 6 minutes later. So my period here is 6 minutes. Looking at part D, during a 50-minute period, what is the greatest number of minutes for which the point A could be higher than 42 meters? So there's two ways we could look at this question. We could use patterns and sequences, or we could use our trigonometry. Let's look at, first of all, using patterns and sequences. And after this, I'll do it out using trig, so you can basically take whichever one you prefer. So if we look at our table here again, we'll scroll back up here for a second. So on our table, we're looking for above 42 meters. So here you can see it's at 42 meters at time 1, and then it drops below 42 at time 5, and then it goes above 42 again at time 7. So I'm basically just going to continue that sequence so you can see what it looks like. So if I scroll back down here again, you can actually see it from my graph here as well. There's time 1, it's coming up to 42, and that's from the table really. And then at 5, back to 42, then it drops below 42 until 7. So as I said, I'm just going to continue that sequence here. So if we come back down, I'm just going to list out all those digits really. So we're going to have time 1, then we're going to have up until time 5, then time 7, and then time 11. So let's just see what that basically means. So from 1 to 5, it's 4 seconds. That's above 42. So I'm going to highlight that as one of my quantities that I need. Then if we were to scroll back up to the table, between time 5 and time 7, that's 2, but that's below 42 meters. So I don't actually need that one. So I'm actually going to leave that one out. So I just basically want to continue this sequence. The next 4 minutes here, I do want to include because that's going to be above 42. So I'm just going to highlight that. And look at it, I basically just continue my sequence. So I'm just going to keep going up here. My next one I'm going up in 2. So that's going to bring that to 13. Then I'm going up in a 4. That's bringing me up to 17. Then in time 2 brings that up to 19. Add a 4 brings me to 23. Add a 2 brings me to 25. Add 4, again, which I'll be above, will bring me to 29. Add another 2 brings that to 31. Again, what I'm trying to do here is just to include 50 minutes. 31, where am I going here? I'm adding another 4, which brings me to 35. Add another 2 brings me to 37. Add a 4, 41. Add a 2, 43. Add a 4, 47. Add a 2, 49, and we'll add another 4 here, and we'll sort that out in a minute. That's going to bring me to 53. Okay, so highlighting the 4s because these are the ones which are above 42 meters. So let's just highlight these ones for a second. So here I have 1, 2, 3, 4, 5, 6, 7, 8 4s highlighted. So I'm just going to go 8 by 4, which is 32 minutes. Next thing I need to do, I need to deal with this little corner going on over here because that's from 49 minutes to 51 minutes. Now, just remember here, I didn't start at time 0. I started at time 1. So here is my time 1. So technically, I have to go, my range here is from 1 to 51 because it wants it in a 50-minute period. But I'm not starting at 0 to 50, I'm starting at minute 1 to 51. So when I come back down to the back end of my table here, let's just see what I have to sort out. I'm at 49, so I basically need to bring this up to what, 51, isn't it? Which means I need to just add on 2 more minutes. I can't add on the extra 4 because it wants it in a 50-minute period. So I just need to add on this extra little section at the end here. So my final answer there would be 32 plus my additional 2 minutes, which would be 34 minutes in total. Let's have a look at this now through trigonometry. So my function given in the question is h of t is equal to 72 minus 60 cos pi over 3 times t. So that's the function I'm given. It's telling us then where it's greater than 42. So I'm just going to let that equal or greater than 42. I'm looking for when it is 42 basically. So I'm just going to use an equal sign here. And I'm going to solve this here. So I'm going to move over my 72 which is minus 60 cos of pi over 3 times t is equal to 42 minus 72, which is minus 60 cos of pi over 3 times t is equal to minus 30. I can divide across by that negative 60 now, so cos of pi over 3t is equal to negative 30 over negative 60. So I have cos of pi over 3 times t is greater than 0.5. So now let's look at our cast, our unit circle now. So we're looking at CAST. So cos is positive, all are positive, sine is positive, tan is positive. And I'm looking now at the angle pi over 3. So it's positive here. That would be my reference angle, and it'd be positive down here where cos, because the function h of t is cos. So they're my two regions that I'm looking at. Now if I come back here and examine our function. So if I solve my function here, I'm going to have pi over 3 times t is greater than cos inverse of 0.5. Now again, just be careful, have your calculator here in radians. So that's giving me pi over 3t is greater than 1 over 3 pi. But we could also have, so let's come over and do it again, or I could have, let's look at this region in here. Now, this region has pi over 3 as our reference angle. How do we get the size of this angle? Well, our full circle is 2 pi, and I'm going to subtract the pi over 3, the reference angle, which is giving me a 5 over 3 pi here. So that's the angle from here to here, basically. That's 5 over 3 pi. So I also have pi over 3 so I have pi over 3 times t is greater than 5 over 3 pi. Now I'm looking for the general solutions here, so I need to add on my plus a rotation, so 2n pi, or 360 basically, and then here plus 2n pi. So I need to do out both of these now, general solutions, by subbing in values for n, 1 rotation, 2 rotations, so on and so on and so on. So let's start. Let's let n is equal to 0, and coming down to my first one here, I'm going to have 1 over 3 pi plus 2 times 0 times pi. Working that out in my calculator now is giving me t is equal to, sorry, that's pi over 3t, I should say. So pi over 3t is equal to 1 over 3 pi. To get t on its own, then I go 1 over 3 pi and basically dividing across by pi over 3, which is giving me a value of t when n is equal to 0 of 1. So t is equal to 1. And I now come over and I'm going to do the same for my other general solution. So let n is equal to 0 here, and I'm going pi over 3t is equal to 5 over 3 pi plus 2 times 0 times pi. So that's going to give me pi over 3 is equal to 5 over 3 pi. And to get t then on its own, divide across by pi over 3. So 5 over 3 pi divided by pi over 3. And that's giving me a value of t of 5. So I just need to basically continue that now. That's n is equal to 0. I just need to continue that until my highest value for t is up to the 50-minute mark, basically. So I just need to keep going with this. So I'm just going to write down some solutions, a few more solutions here. So let n is equal to 1, let n is equal to 1. When I let n is equal to 1, I get t is equal to 7 and t is equal to 11. When I let n is equal to 2, I'm getting t is equal to 13, t is equal to 17. When I let n is equal to 3, I'm getting t is equal to 19, t is equal to 23. Let n is equal to 4, I'm getting t is equal to 25, t is equal to 29. Let n now equal to 5, t is equal to 31, t is equal to 35. Let n is equal to 6. I have t is equal to 37, t is equal to 41. Let n is equal to 7, t is equal to 43. And let n is equal to 7 again, I get t is equal to 47. And I'm going to go one more time. I let n is equal to 8. And I'm getting t is equal to 49. T is equal to 53. Okay, so what does that mean now? You can hopefully see that the gap between each of my times, so the gap here between, say, 19 and 23 is 4 minutes. Here it's 4 minutes, so it's 4 minutes each time. So if I just zoom out a little bit more here, we'll try and visualize that all the way to the 0 here. It might be a little bit small, but the gap that you can hopefully see is now 4 minutes between each. So 4, 4, 4, 4, 4, 4, and 4. So how many 4s is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 4s. Sorry, yes, that's 9 4s, but we need to exclude this one because it goes above the 49 to the 53 because it only goes up to 50-minute period here. So that's 8 4s. So therefore my final solution here would be 8 times 4, which is 32. And on to that, I need to add on 2 additional minutes because these additional minutes are from, we started at t equals 1. So if I'm starting at t is equal to 1, I need to bring that all the way up to t is equal to 51 because remember, this has to be a 50-minute time scale. So I'm not starting from 0 to 50, I'm starting t is equal to 1. So in a 50-minute period, that is going to go from 1 to 51. So that's why I'm adding on the extra 2. So that's giving me 34 minutes in total. Part E. By solving the following equation, find the second time value of t that the point A is at the highest, the height of 110 meters. So we're solving the equation here. So 72 minus 60 times cos pi over 3t is equal to 110. So first thing I'm going to do is move over the 72 or subtract 72 from both sides. So that's giving me minus 60 cos of pi over 3t is equal to 110 minus 72, which is giving me a value of 38. I then divide across by the 60, so cos pi over 3t is equal to 38 divided by negative 60, I should say, which is giving me cos pi over 3t is equal to minus 19 over 30 when it simplifies down. If I do cos inverse of that, I get pi over 3t is equal to cos inverse of negative 19 over 30, which is giving me pi over 3t is equal to 2.2566. And to get t in its own, I divide across by pi over 3. So 2.2566 divided by pi over 3, which is getting me a value of t of 2.15 minutes. And if you come back up to your picture here, your sketch in part B, look at 2.15 and it's 110 meters. So 110 meters is roughly here, which looks about right. It looks about 2.15 meters. Now we're looking for the second time. So the second time is over here now. So we're looking for this time, and that looks, it's somewhere above 3.5. So we're probably looking for maybe 3.7 or 3.8 minutes. So that's what we need to prove now for the second time in part E. So from my log tables on page 13, I know that 1 radian is equal to 57.296 degrees. That's from page 13 in the logs. Now, that tells us then that if I want 1 degree, it would be 1 radian divided by 57.296 degrees. And then to get 180 degrees, I multiply this by 180, which is giving me an equivalence of 180 degrees as 3.14 radians. So that's what the value of 180 degrees is in radians. Now, coming back to our question here, we know that using our cast again, so if we look at our CAST here, all positive, sine and tan are positive. Now I'm looking at where cos is negative because it's minus 19 over 30. So it's negative here. And it's also negative then in tan being positive, so negative in here. So my first answer I got was 2.25 as my answer over here. So this value here. So if I come back now to my radians and find the size of the reference angle in here. So I have the full semicircle, or half of my circle here, to be 3.14 radians. I subtract the angle I already have, which is 2.25, and I get 0.89. So this angle in here, my reference angle, is 0.89. So to get this angle then in here, I need to go my 3.14 plus my reference angle, 0.89, and that's giving me 4.03. So the size then, let me just sketch it out neatly here on a separate coordinate graph. So this angle in here, where tan is positive, this angle from here to here is 4.03 radians. So there's 4. I'm now going to come back down. I'm going to take this section here, redo it, but letting it equal to 4.03. So my final step here is going, I'm running out of space here. So I'm going pi over 3t is equal to 4.03. Solving for t, so t is equal to 4.03 divided by pi over 3. T is equal to 3.85 minutes. So that's our second value for t. Part F, use integration to find the average height of the point A over the first 8 minutes that the wheel is turning. Give your answer correct 1 decimal place. So the key here to this question is where it says the average height. So we're basically finding the average value of a function, and the function that we're given is 72 minus 60 cos pi over 3 times t. So in this question, we need to integrate our function, and then we're going to find the average value of it. So we're basically going to integrate 72, so that'll become 72t. And when we integrate cos, we get sine, so it's going to be minus 60 times sine pi over 3t. And then we divide by the value in front of our variable, the t, so that's pi over 3. So that's the integral of our function. Now we need to find the average value of that, and the formula for the average value, or the process to carry that out, is the fraction 1 over b minus a. And then we need to find our integral from the limits b to a and our function h of t. So we have our value, so it's to the first 8 minutes. So setting up, it's going to be the average value from 8 to 0, the first 8 minutes. So that's 1 over 8 minus 0. And I have my function h of t. So subbing that into my integral, it's going to be 72 times my t, which is 8, minus 60 times cos pi over 3 times t, which again is 8. And from that, I need to subtract the integral, or the value when I sub in 0. So subtract 72 times 0 minus 60 times sine of pi over 3 times 0. And I forgot, actually, this is all over pi over 3. So I'm subbing in 0 this time for t. And don't forget, I need to multiply all of that by my average value. So to the front of this, so let me just change the color of the brackets here. So all of this needs to be multiplied by 1 over 8 minus 0, which is 1/8. So how's that going to look? So I'm going to have 1/8 times, multiplying all this out now in my calculator, 576 minus 49.62, subtract, well, 72 times 0 is 0, and this will also give me 0. So that's going to be 1/8 of 526.38, subtract 0, which is giving me 1/8 of 526.4 if we round it to our 1 decimal, which is giving me an answer of 65.8 meters. And that's part F complete. Question 9. Alex gets injections of a medical drug. Each injection is 15 milligrams of the drug. Each day the amount of drug left in Alex's body from the injection decreases by 40%. So the amount of drug left in Alex's body t days after a single injection is given by the following function. Part A, find the amount of the drug left in Alex's body 2.5 days after a single 15 milligram injection. Give your answer in milligrams, correct to 2 decimal places. Okay, so again, it's kind of text heavy here, but a couple of things we just need to remember. The injection contains 15 milligrams, decreases by 40%. So that's why it's gone to 0.6, because it's 1 minus 0.4. And it's in t days. So t stands for the number of days. So looking at part A here, they're basically just getting us to sub 2.5 in for t, because it's 2.5 days. So I'm just taking my function 15 multiplied by 0.6 to the power of t, and I'm basically subbing in 2.5 for my power, for t. And when I work that out in my calculator, I'm getting 4.1823, and it wants it to 2 decimal points, so that's 4.18 milligrams. Moving down to part B now. How long after a single 15 milligram injection will there be exactly 1 milligram of the drug left in Alex's body? Give your answer to 1 decimal point. Again, I'm taking my function from the top of the question, 15 times 0.6 to the power of t. Now the question is asking us to find how long, so that's asking us to solve for the power of t. Find the value of t. Now it wants it to have a value of 1 milligram after a certain amount of time. So I'm going to let my function equals to 1. I'm going to solve this now. So first thing I'm going to do is divide across by 15. So that gives me 0.6 to the power of t is equal to 1 over 15. I'm then going to go to my log tables from page 21 now and use the rule at the top right hand corner of that page, which is given as a to the power of x is equal to y is the same as log y to the base a is equal to x. So that's the rule I'm using here now. And filling that in, my a is going to be t. That's the power. that's going to equal to the log of y. My y in this case is 1 over 15 to the base of a, which is 0.6, and that's equal to my t. So I just need to now type that into my calculator, the log of 1/15 to the base 0.6, and that's giving me 5.301. Question wants it to one decimal place, so how long does it take? So t is equal to 5.3 days. Part C, Alex is given a 15 milligram injection of the drug at the same time every day for a period of time. Part C, explain why the total amount of the drug in Alex's body immediately after the 4th injection is given by the following expression. Okay, so let's look at building this expression. Might be one way of looking at it. Let's look at today, day 1. What's happening today with the drug? So our function is 15 times 0.6 to the power of t. So imagine I'm basically just about to start my course of injections. I'm just about to start my stopwatch. So that's basically right now, which would be the power of 0. And that means that when I put the injection into my arm, or Alex puts it into his arm, 0.6 to the power of 0 is 1, 15 times 1 is 15. So that means there's 15 milligrams straight away in his body, and that's that 15 here. Let's then look at what happens tomorrow, day 2. So same principles again. I take my function 0.6 to the power of t, and I'm in a full day 24-hour period. So this time tomorrow would mean that my power is to 1 because it's tomorrow. And when I evaluate that, I'm getting 15 times 0.6, and I'll just keep it as 15 times 0.6 because that's this one here. And I'm just going to do one more. I don't think we need to do out all 4. I'm going to do day 3 now. Again, taking my function, 15 times 0.6 to the power of t. I'm looking at day 3. So I'm putting it to the power of 2. So see how my powers don't actually match today because day 1 was to the power of 0. And that's giving me 15 times 0.6 to the power of 3. Now you can do out day 4 if you want, but you can hopefully see that I'm building up a geometric series here because I'm adding them together. So therefore, building my series here, I have 15 for day 1 plus 15 times 0.6 for day 2 plus 15 times 0.6 to the power of 2 for day 3, and so on and so on and so on. Now maybe, I don't know, I haven't checked the marking scheme here, so maybe we'll just do out day 4 maybe just to be safe. So perhaps just do out day 4. Looking now at part D to this question. Find the total amount of the drug in Alex's body immediately after the 10th injection. Give your answer in milligrams, correct to 2 decimals. So if we use our knowledge here from part C, we have a geometric series. This expression that they gave us in part C basically represents the amount of the drug in his system after any amount of days. So that's the sequence here, and it goes on and on and on and on to infinity. So 15 times 0.6 to the power of t. And if I go to my log tables now and go to page 22, so page 22 in our logs here, you can see the formula for the sum of a geometric series. So it's given as Sn is equal to a times 1 minus r to the power of n, all divided by 1 minus r. And just filling in our pieces of information here, my value for a is the first term, so that's 15, the first term in my sequence. My r is what I'm going up by each time, the ratio. So if I take any term, so let's say take term 2 divided by term 1. So we would have 15 times 0.6 over term 1, which is 15. The 15's cancel, so my common ratio here, I'm increasing by 0.6 each time, basically. That's what that's telling us. So let's sub that in now to my formula. So I have Sn, so I'm looking for S of 10. So I have S10 is equal to A 15 times 1 minus R to the power of n, 15, all over 1, sorry, my power is not 15, our power is 10 days, isn't it? And it's 1 minus r, which is 1 minus 0.6. Working that out, I get the sum of the first terms to be 37.273. Question wants it to 2 decimal points, so 37.27 milligrams. Part E, use the formula for the sum to infinity. Okay, so that formula is from our log tables on page 22. So they're giving us a hint there that we have to use this formula. So that's the sum to infinity is equal to a over 1 minus r. So use the formula for the sum to infinity of a geometric series to estimate the amount of the drug in Alex's body after a long period of time. So we are going to use our sum to infinity. So sum to infinity is equal to a, again from part D, is our first term, which is 15, over 1 minus r. My r is my common ratio, again from part D, is 0.6. So that gives me sum to infinity of 15 divided by 1 minus 0.6, which is 37.5 milligrams. Part F, Jessica also gets daily injections of a medical drug at the same time every day. She gets d milligrams of the drug in each injection. Each day the amount of the drug left in Jessica's body decreases by 15%. Use the sum of the geometric series to show that the total amount of the drug in Jessica's body immediately after the nth injection is given by the following expression. So the first thing I'm going to do here is basically come back to Alex's injection. You remember Alex's injection was given as 15 times 0.6 to the power of t. So I need to maybe make use of that. So if I use my what will we use? Our compound interest formula. So you know our compound interest formula is given by 1 minus our interest rate, but in this case it's going to be 1 minus what it decreases by, basically, and it's decreasing here by 15%, and 15% is 0.15 and to the power of t, and that's going to give me then 0.8 to the power of t. Now what we don't know though is the amount of drug she gets. We know that that stands for d. Now in Alex's, the amount of drug he got was 15 milligrams. So I'm just going to keep that 15 as a d for Jessica. So it's d times 0.8 to the power of t. That's the amount of drug that Jessica is going to get every day of the week. Now let's set up a sequence here for a continuous amount of days. So let's set up a geometric series. So we're going to do day 1. And what's happening on day 1? So she's taking some amount of drug, 0.8, sorry, that should be 0.85, my fault, 0.85, and it's going to be to the power of 0 because once again, she's taking it right now. That's the time I start my stopwatch, so no time has passed when the first injection goes in. Then I'm looking at day 2, so I'm adding on the amount of drug that's in her after day 2. So that's going to be d times the amount of drug, 0.85 to the power of 1, and so on and so on. So let's do out 1 or 2 more. So day 3, 0.85 to the power of 2, and so on and so on and so on, up until maybe, let's call it day n, because the question is talking about the nth day. So that's going to be d times 0.85 to the power of n. So using our sum of the sequence or the series from our log tables on page 21, it's Sn is equal to a times 1 minus r to the power of n all over 1 minus r, which is giving us then a first term a of d, because d, this is my first term technically, and 0.85 to the power of 0 is 1, and 1 times d is d, so my a is d, and my common ratio, is what it's going up in. So again, take term 2 divided by term 1, which is d times 0.85 to the power of 1 divided by d, because d is my first term. The d's will cancel, so my common ratio is going up by 0.85 each time. So that's everything I need now for filling in my Sn formula. So filling it in, I'm getting Sn equals d times 1 minus or 0.85 to the power of n divided by 1 minus or 1 minus 0.85. So that's leaving me then with Sn is equal to, I'm just going to put a 1 in front of this d if it helps. So 1d times 1 minus 0.85 to the power of n all over 0.15. Now look what happens. Come out here to the side maybe. I'm basically going to divide this 0.15 into this 1. So I'm dividing 1 by 0.15. And when you go to your calculator and divide 1 divided by 0.15, you get 20 over 3. So that means that this here is the same. So it's an equivalent fraction basically. 1 over 0.15 is the same as 20 over 3. So my final solution here is Sn is equal to, instead of 1, I'm calling it 20. And instead of 0.15, it's going to be 3, because that's an equivalent fraction. So it's 20d times 1 minus 0.85 to the power of n and all over 3. And that's, if you scroll back up, oh sorry, it's gone a little bit too far. That's basically what they wanted us to show. Part 2, immediately after the 7th injection, there are 50 mg of drug in Jessica's body. Find the amount of drug in one of Jessica's daily injections. Give your answer to the nearest mg. So basically what we're doing here, we're going to take the formula there from F part 1, and we're basically going to let that equal to 50 mg, because that tells us the amount of mg in our body at any time. So that's my first step. So I have my 20d times 1 minus 0.85 to the power of n, all divided by 3. And I'm letting that equal to 50 because there's 50 mgs. Now I also know n is standing for 7th injection in this case. So I'm subbing in 7 for my n. So rewriting my equation here, I'm going to have 20d times 1 minus 0.85 to the power of 7 all over 3 is equal to 50. I'm going to, there's different ways we can do this. I'm just going to put this over 1 and cross multiply here. Fraction is equal to fraction. So that's going to give me 20d times 1 minus 0.85 to the power of 7 equals 350s, which is 150. Dividing across by the 20 will give me d times 1 minus 0.85 to the power of 7 equals 150 over 20. If I work out now what's inside my bracket here, that's going to give me d times 1 minus 0.320577 equals 150 over 20, which simplifies to 7.5. And taking 0.32 away from 1 will give me d times 0.6794. I'm just going to go to a good few decimals here. Equals 7.5. So to get d in its own, I'm going to divide across by 0.679. So that's going to give me then, when I type that into my calculator, a d of 11.03878. Now the question wants it to the nearest mg, so that's 11 milligrams. Question 10a, find a proportion of the digits recalled correctly after 3 hours according to this model. Give your answer correct to 2 decimal points. So what this question wants us to solve for is basically when time is equal to 3. So t stands for hours. They want it after 3 hours. So I'm subbing in 3 for t into my function. So everywhere I have a t, I'm basically subbing in a 3. So I'm basically finding p of 3. So that's 0.82 minus 0.12 ln of 3 for t, and then add on my 1. So that's giving me p of 3, which is, when I work this out in my calculator, 0.653645. and it wants it to two decimal points, so that's 0.65. So the proportion of digits recalled is 0.65 of the digits, or as a percentage, that would be 65%, but the question doesn't want it as a percentage, it wants it to 2 decimals. Moving down now to part B, after how many hours would exactly 55% of digits be recalled correctly according to this model? Give your answer again to 2 decimals. So I'm taking my function from the top of the page, 0.82 minus 0.12 times the natural log of t plus 1. Now this gives me the proportion of digits recalled. Now the proportion of digits being recalled here is 55%. My next step, I should say, is to write that as a decimal. So t plus 1, and 55% as a decimal, divide 55 by 100 because there's 100%, is 0.55. Next step I'm going to do is move over this as 0.82, or subtract 0.82 from both sides. So just rewriting that is going to give me 0.55 minus 0.82. And tidying that line up now is going to give me minus 0.27. I'm then going to divide by the minus 0.12 because it's stuck to that log. So that's giving me ln of t plus 1 is equal to minus 0.27 over minus 0.12. The two minuses there will become a plus, and 0.27 divided by 0.12 is giving me 9 over 4, or 2.25 basically. The next step now is coming from my log table. So I need my logs here now on page 21. And I'm using the top right hand corner here of the log tables, which has a to the power of x is equal to y, is the same as, or implies that the log of y to base a is equal to x. So I'm using this here to help us solve for t. Now if I just come back down here, I have the natural log of t plus 1. Now that's the same as, so ln of x is the exact same as me writing that as log of x to the base e. So that's my natural log. So I'm just going to rewrite this here as log to the to my x, which is t plus 1, is equal to 9 over 4. So I'm just rewriting my log there. Instead of calling it ln, I'm writing it in terms of the log. Okay, so we're basically working backwards here. So my a is going to be my base, which is e. I want to put that to my power, which is my x, which in this case is my 9 over 4. And that's equal to my y, which is t plus 1. And when I evaluate the left-hand side on my calculator, e to the power of 9 over 4, that gives me 9.4877 is equal to t plus 1. Subtract 1 from both sides, or move over that 1, is giving me 8.4877. So I just subtracted from 1 there. Subtracted the 1. And the question wants it to 2 decimal points, so that would give me 8.49 as my value for t. So 8.49 hours basically is what this is getting us to do. Part C, part 1, find the value of p dash of 1. So this is the derivative of the function. So just taking down my function from the previous part, I get to differentiate this now. So p dash of t, so I need to differentiate it before I can sub in 1. Differentiating the constant will go, so that's leaving me with minus 0.12 times the derivative of ln 1 or t plus 1. Using my log tables, that's giving me 1 over t plus 1. So that's the derivative of p of t. Now I'm going to solve that for p dash of 1. So everywhere I have a t, I'm subbing in 1. So that's giving me 1 plus 1, isn't it? And when I work that out, I'm going to get p dash of 1 to equal minus 0.12 over 2, which is the same as minus 3 over 50. Part 2, p dash of t is always negative from 0 to 12. What does this tell us about the proportion of digits recalled correctly after t hours according to this model? Well, one thing we could say there is that the proportion of digits recalled between the times of 0 to 12 is always decreasing because it's negative. So that's C part 2. Moving down then to part D, use calculus to show that the graph of y is equal to p of t has no point of inflection. So just recall here, how do we actually show or find the point of inflection? So point of inflection is found when your second derivative is equal to 0. So when you solve your second derivative and let it equal to 0. Now our function p of t from the previous page is 0.82 minus 0.12 ln t plus 1. From C part 1, we found the first derivative to be minus 0.12 over t plus 1. So that was our first derivative. Now I need to get the second derivative. So in order to find the second derivative, I have a fraction here. So I'm going to use, from my log tables, my quotient rule. So I'm using the quotient rule here now. So my u is equal to the numerator minus 0.12. Differentiating my numerator, it's just going to become 0. I get my v, which is the denominator, t plus 1. Differentiating the denominator, I'm just differentiating t, so I get 1. So subbing them in now to my quotient rule, I'm getting v, which is t plus 1, times du, which is 0, minus u, which is minus 0.12, times dv, which is 1, and that's all over v squared, which is t plus 1 to be squared. So again, that's the quotient rule from my log tables. Letting that equal to 0 because it's the point of inflection. So working that fraction out, I get 0 minus minus, which becomes a plus 1 or 0.12 all over t plus 1 squared equals to 0. I want to solve this fraction, so I'm going to put the 0 over 1 and cross multiply. So 1 times 0 plus 0.12, well, that's just going to give me 0.12. 0 times t plus 1 all to be squared. Multiplying that by 0 is actually just going to leave me with 0. So you can see here now that I have 0.12 is equal to 0, but I'm going to say, since 0.12 is not equal to 0, clearly, then therefore no point of inflection, because I would have been hoping to get 0 is equal to 0 in order to prove it had a point of inflection. Looking now at part 1, if we learn a skill and then don't practice it, how well can we do? It usually decreases over time. For example, if you learn to play the guitar and then don't play the guitar for a number of months, you'll probably not be as good as playing the guitar the first time you try it again. This effect can be modeled by the following equation. So part 1 says write C in terms of log a to the base 10, log b to the base 10, and log t plus 1 to the base 10. Okay, so this is basically just manipulation of the function or the equation that we're given. We'll need your log tables on page 21 to answer this question here. So let's begin and see what we have. So I have b times t plus 1 to the power of c is equal to a. So that's what they're giving us. Let's just isolate the t plus 1 to the power of c. That's the same as dividing across by b. So t plus 1 to the power of c is equal to a over b. Okay, so nothing major there. Log tables now, page 21. Let's see, can we start changing this around a little bit? So from the logs, we know that a to the power of x is equal to y. Implies that log of y to the base a is equal to x. So that's page 21, bottom right hand corner. So let's change this around a wee bit. That then will give us log of my y. My y in this case is a over b. To the base of a, well, the base here, a little bit trickier. The base here is going to be t plus 1. And that's equal to my x, which is going to be my c, which is my power, in other words. So now I've got c is equal to log of a over b to the base t plus 1. And I'm doing that because the hint is in the question, because it wants us to write each of these in log form. Next thing I want to do now is look at the question. It wanted to base 10. So I'm going to now use the bottom right hand formula on page 21 of the logs. And on the bottom right hand corner, it's given as, let's just write it down, log of x to the base b is equal to log of x to the base a over log b to the base a. So in this question here, I'm trying to get rid of my base, which is t plus 1. So in other words, that's my b in this question. And I'm trying to change it to a base of 10. So manipulating this now, I'm going to leave myself with, well, let's just write it all out again. So I have c is equal to log of a over b to the base t plus 1. And I'm now going to change that to log of a to the x. Well, that's going to give me log of a over b to the base 10 all over log of my b, which is going to be my t plus 1, to the base 10. Now, I can actually change that top line. Look at the way I've log of a over b to the base 10. Go to page 21, second rule down on the middle column. How do I deal with a fraction? I subtract them from each other. So that's going to give me the same as log of a to the base 10 minus log b to the base 10 all over log t plus 1 to the base 10. And I think I'm done, because the question wants us to write c in terms of log a, log b, log t plus 1. And that's what I've done. Final part, E part 2. A student got 80% on a guitar exam. After 2 years of not playing the guitar, the student got 47% on the same exam. Use this to find the value of c in the model above, correct 3 decimal points. So using the equation from above, a is equal to b times t plus 1 to the power of c. So that's coming from the top of the question here. A is going to be the grade that the student got in the original exam, the measure of how well you've done at time 0. So A is going to equal to my 80%, the original exam. That's 0.80 as a decimal. B then is going to be the measure of how well the student has done sometime into the future. So that's my 2 years later, in other words. So that's my 47%, which is going to be 0.47. Now, t in the question here is 2 years. But if you go back up to the top of the page here, it tells us that t is measured in months. So I need to convert 2 years into months. So 12 times 2 is 24 months. So t is equal to 24 here. Now I basically just have to sub that in to my equation. So I'm just going to box that off. That's a little bit of rough work there. So I have A, which is 0.80, is equal to B, 0.47 times T, which is 24 plus 1 to the power of C. C is what I'm trying to solve for here. So 0.80 is equal to 0.4725 to the power of C. Let's just isolate the 25 to the power of C on its own. So 25 to the power of C is equal to 0.80 over 0.47. I'm dividing across by that 0.47 basically. So how's that looking now? Let's again use our logs, page 21, bottom right hand corner here, which is given as a to the x is equal to y, is the same as the log of y to the base a is equal to x. So I'm going to use this now to help me solve for c. So that's going to be log of my y, which is 0.80 over 0.47 to the base of 25 is equal to c. Working that out now in my calculator, I'm getting 0.16524 is equal to c. Question wants it to 3 decimal points, so c is going to be 0.165.